Hello, Course 3 students. Here is what we are doing in this video. We are going to be doing Unit 2, Lesson 2.3, Part 1. So this lesson typically has adding and subtracting rational numbers together. But to be honest with you, working with rational numbers is pretty difficult. And so I wanted to break it apart into two different parts, on adding as well as subtracting. And so our objectives are I can add rational numbers and I can solve real life problems. So sometimes you're going to see that I have different kinds of slides. These are things I had from previous years, or sometimes I'm making them as we go along. So let's talk about adding our rational numbers. Remember, rational numbers are anything that can be written in the form of a fraction. So it could be a fraction, it could be a decimal, it could be a whole number. So it says to add rational numbers, use the same rules for signs as you use for integers. So basically, you need to think about your integer addition rules, which means same signs add, different signs subtract. So in this case, they have negative 1/3 plus 1/6. First thing they do is they change it all to the same denominator. That's what we usually typically do when we're adding or subtracting fractions. So they changed this 1/3 into 2/6. I think I'd mentioned in another video, just take that negative part and bring it up to the numerator. So now you have negative 2/6. And that means the same thing whether it's out in the middle or if it's out top. So then I want to add, well, 6, we don't add the bottom. This denominator stays the same. We only add the top part. So in that case, we have negative 2 plus a positive 1. They are opposite signs, so we end up actually subtracting them. So I think the absolute value of negative 2 is 2, the absolute value of 1 is 1, 2 minus 1 is 1, and I keep the sign of what was the larger when I had the absolute value, which is negative 1. So now I have negative 1/6, and you can write it like this, or you can write it like this, so either one is fine within your writing, but making sure that you keep those positive or negative values if those are what are going to stay with it, depending on how you're adding those rational numbers. So let's go ahead and take a look at a couple examples. So I think I have about 4, maybe 5. We'll see how far we can get with them. So in this first one, we got another fraction addition. And I noticed that I have negative 8/3 as well as a positive plus a positive 5/6. Now I have a third on the bottom and I have a 6. So let's get these so that they have the same denominator. My easiest way is to multiply this fraction by 2 on the top and the bottom. I'm also going to take that negative and bring it up to the top. So if I had negative 8 times 2, that gives me negative 16. 3 times 2 is 6. Plus then 5/6. Remember, when I'm adding fractions, my denominator stays the same on the bottom unless at the end I decide to simplify. And then I'm really only adding the top part. So negative 16 plus a positive 5. So if you're thinking about your number line, maybe you're at negative 16 here, and I need to jump 5 places to the right. Okay, so I would think, okay, negative 16, one more would be negative 15, another one, so on. Or you can think about those integer operation rules, knowing that these are opposite. I take the absolute value of negative 16, which is 16. I take the absolute value of 5, which is 5. They're opposite signs, so I subtract them. 16 minus 5 is 11, and I keep the sign of the larger absolute and what it originally was, which was negative. So in this case, I'd have 6 with a negative 11 as my numerator. I'm okay if you want to leave it as this improper fraction, but if you would like to change it into a mixed number, it would look something like this, 1 and 5/6. Either is fine for me. I'm not going to be picky on having which form. So you can have either or, they mean the same thing. Alrighty, how about if we had to add decimals? So again, my integer rules are still going to stay the same. Same signs add, different signs subtract. And so what I'm noticing here is that they're different signs. So I think the absolute value of both, I take the larger and subtract the smaller. So in this case, I'd really have 7.62 minus 4.05. We are not using calculators, so I would always suggest setting it up this way because that's going to help you set up for your long subtraction. I can't do 2 minus 5, so I'm going to take 1 over. We're going to start solving this. I believe that's 7, 5, and then I'd have 7 minus 4, which is 3. And the larger one was the positive version, so it's going to be a positive 3.57. Okay? Hey, code word. I haven't done code words in a while. Let's find something different. I'm wasting all your time. Sticky note. That's your password. Let's keep going. Alrighty, so example 3 now. We are still adding rational numbers, but we're adding in skills that we've learned in our previous units so far. And the skill that we're adding in is substitution. So we are adding in substitution into this equation, okay? So we are going to solve 2x plus y when x is 1/4 and y is negative 3/2. All right, first off, let's go ahead and substitute in our values. So I have 2x, so I'd have 2 times whatever x is. And you can put a parentheses here, or you can just put the multiplication, but I like to put the parentheses. Remember, this shows me multiplication anyways. Plus then what y is, and y is negative 3/2. And I already brought that negative up to the top. What I'm noticing here is I can multiply this first. Because remember, it's a lot like saying 2 out of 1 times 1 out of 4. We multiply across. Well, 2 times 1 is 2. 1 times 4 is 4. And then I'd have, in this case, actually, let's erase this. I have a plus a negative. Remembering that plus a negative actually changes it to a subtraction problem. And so let's go ahead and write that as a subtraction problem then. So then I could say something like minus 3/2. So the negative goes into the operation now, and then this turns positive. Now I don't have the same denominator, so that's going to be my next step. I see 2 different ways I could go about this. One way is I could go ahead and be like, you know what, I'm going to change this into fourths, and then I will subtract from there. So I could multiply the bottom and the top by 2, but also I know that I can simplify this fraction to 1/2. So then really I have 1/2 minus 3/2. So again, this actually turned into a subtraction problem rather than an addition, even though I told you we were going to practice addition. But that's where, you know, sometimes they're a little interchangeable, and that's why I wanted to take a little more time to go through, practice a little more addition with a little bit of subtraction, and then we'll practice more subtraction with some addition. And so the 2 stay on the bottom as my denominator, but then I have 1 minus 3. So if I'm going 1, and I'm going to go back 3 places, I end up at negative 2, and I'm out of 2. Hey, we can simplify this though, because 2 out of 2 is 1. The only thing that's different about this is I have a negative 1 now. Alrighty, let's keep going. I think we're going to skip this 4th one because I want to be able to look at these ones. Now, this is from an old slides that I had from a previous year, and I'm not going to have you do these ones on your own, but I want to take a look at them, and I only really want to take a look at 8 because this is something I noticed from other assignments that students are getting confused about. When I have absolute value bars and I have an operation within the absolute values, I need to do the operation first before the absolute value. So operation first, is it 2 P's? I'm not 100% sure. Operation first, then absolute. So in this case, let's set it up. I have these absolute value bars. I have A plus B. A is 1/2, plus then I have -5/2. So remember, we also just talked about how adding a negative just ends up turning into a subtraction problem. So really, I have 1/2 minus 5/2. We need to solve this operation before changing this into positive. So I shouldn't have changed, you know, some people think, okay, 1/2 plus a positive 5/2. Nope, I want to do this operation first, then take the absolute value. So within here then, remember the 2 stay at the bottom, and then I'd have 1 minus 5, which is actually really -4. And then I want to, let's simplify this first, because what's 4 divided by 2? 4 divided by 2 is 2, so I'd have -2. And then I take the absolute value of -2. This is where I'm taking the absolute value finally, and it is a +2 then, okay? So always in those cases, take the operation first and then the absolute value, okay? I will see you guys later as we work through problems about adding your rational numbers. Let me know if you have any questions. Make sure to submit your code word.